Hello everyone, this is Jyoti Katgi, ENC Department, BGMIT Madhav. Today we'll do the experiment number 4B, that is second order high pass filter. In the last video you have studied second order low pass filter. Now second order Butterworth high pass filter. The aim of the experiment is design an active second order Butterworth high pass filter. Active means active components are used as op amp. Butterworth means in the low pass band as well as in the stop band you get a flat waveforms. Okay, the circuit diagram for the high pass filter is shown in figure here. Here you are using the op amp 741 in a non-inverting mode. Then output you are measuring across the pin number 6 in the CRO. Then resistors R3 and R4 I have used here as 10 kilo ohms, R1 and R2 as 2 kilo ohms, C1 and C2 as 0.1 microfarad. Since it is a second order filter, therefore you are using two pairs of RC circuit, that is R1C1 and R2C2, and input you are giving to the one end of the capacitor C1. Next, after doing all these calculations, circuit diagram, connections, after doing this connection, the tabular column for this experiment is shown in figure here. Tabular column is shown here. The cutoff frequency I have taken here for this experiment as Fc is equal to 5 kHz. The input voltage Vin I have taken as 2 volts peak to peak. Here we are varying the frequency and you are measuring the output voltage. Okay, here I have varied the frequency from 900 Hz to 7 kHz. Since I have taken the cutoff frequency as 5 kHz, around 5 kHz, more readings I have taken. Then by varying, suppose if I keep 900 Hz, I got the output voltage as 3.8 volts. Then after varying all these frequencies from 900 Hz to 7 kHz, you have to take down the output voltage. For 1 kHz 4.8 I got, 2 kHz I got 6 volts. Similarly vary other frequencies and take down the output voltage. Then after measuring the output voltage, we need to calculate the gain of this, that is output voltage by input voltage. Input is 2 volts and different output voltages are there, take the ratio, you will get the gain. Then next you have to calculate the gain in dB, that is 20 log of V0 by Vin. Okay. Then you will get a graph for this experiment as this one, output waveform. Here along x-axis we have taken the frequency and y-axis we have taken the voltage gain in dB. Okay, you need to draw this graph in some log sheets. Next, see here, first the frequency, what it will be, gain will be increasing at the 40 dB per decade rate. Then after the cutoff frequency, it will remain constant. Because it is a high pass filter, it will allow the higher frequencies and attenuate the lower frequency. Therefore, you will get first the stop band and next the pass band. FL is the cutoff frequency. Here you have taken the cutoff frequency as 5 kHz. Okay, plus 40 dB per decade increase is there because it is a high pass filter. For this connection, circuit diagram, I have done the experiment connections here. See. Here I use the op amp, 2 kilo ohm resistors and 2 10 kilo ohm resistor and 2 0.1 microfarad capacitors. And input I have given from the signal generator, output as well as input we are measuring in the CRO, and we are used the DC power supply. For pin number 7 I have given 12 volts plus 12 volts and pin number 4 I have given minus 12 volts. By varying the input frequency, we will measure the output voltage in the CR. Here, the first waveform is the input voltage. You need to measure what will be its peak to peak input voltage. Next, by varying the frequency, you have to measure the peak to peak voltage of the output waveform. Here, now I kept at the frequency as 1.8, around 1.8 kilohertz I kept. This waveform I am getting. Suppose what you have to get, you have to first the waveform output voltage should increase, then after some frequency it has to remain constant. That means around 5 kHz it has to remain constant. After 5 kHz Now I will vary the frequency. Before, for the smaller frequencies, suppose for 500 Hertz is there. Okay, here I kept the 500 Hertz. For that you are getting the waveform. Here this one is the input waveform and this is the output waveform. For 500 Hertz, okay, this is the waveform. If we are varying the frequency, the amplitude goes on increases of the output waveform. After or around 5 kilohertz, it will remain constant. Okay, around 5 kilohertz it will not vary, it will be remaining constant. See here, now I kept the frequency as 4.5, around 5 kilohertz I kept, the output is remaining constant. It is not decreasing or increasing, it will be remains constant. Okay, that means first for higher frequencies it will allow and for lower frequencies it will attenuate because it is a high pass filter. Okay, this is about the second order high pass filter using 741 op amp. Thank you.